Hey there, and welcome. Have you ever walked past a brick wall and just noticed things that look a little off? Some cracks here and there, or maybe those weird white stains that seem to pop up after a rainstorm? Well, guess what? Those little imperfections are actually huge topics in competitive engineering exams like the KPSC AE or the SSC JE. So let's break down what they are and why they're so important. So this is exactly what I'm talking about. You've seen this before, right? These white kind of powdery patches all over a brick wall. It almost always shows up after things get wet, so you have to wonder, what is that? Is it a problem with the brick, the mortar, something else entirely? This is a perfect example of a classic exam question hiding in plain sight. And that's exactly what we're going to do here. In just the next 5 minutes, we're going to break down the essential science of making and testing bricks. We'll boil it all down to just the key facts that you'll actually need to remember on exam day. Okay, so first things first, let's start by digging into that white powder we just saw. Because, sometimes the best way to understand what makes a brick good is to first get a handle on why they sometimes go bad.
So that white powder, it actually has a technical name, efflorescence. And what causes it is pretty interesting. It's not something on the outside of the brick, like mold or paint. It's actually salts that are coming from inside the brick itself. The specific term you absolutely have to remember for your exam is alkalis. These soluble salts are the culprit here, and that is the keyword that examiners are looking for.
So to avoid issues like efflorescence, it really all comes down to making the brick correctly right from the very start. Let's quickly walk through the manufacturing process, but we're only going to hit the critical steps that always seem to pop up in exams. The journey from just a pile of dirt to a solid brick begins with preparing the clay. This has 5 main stages: unsoiling, digging, cleaning, weathering, and finally tempering. Now, while all of them are part of the process, exams tend to focus really heavily on that very last step. And that final step is called tempering, though you might also see it called pugging. It's done in a machine called a Pug Mill, and its entire job is to make the clay plastic. Now, that doesn't mean it's made of plastic, of course. It just means we're kneading it with water until it has that perfect, uniform consistency to be molded. So the key takeaway here? Tempering equals plasticity. Lock that one in. All right, so once the brick is molded, you get this little indentation on top. It has a pretty strange name, a frog. But what does it actually do? This is a classic question that's really designed to test if you know the practical side of things, not just the theory. Now, a lot of people think it's there just to save a little bit of clay, but that's a total myth. For the exam, you need to know it serves 2 main purposes. First, and this is the most important one, it creates a key, sort of a shear lock for the mortar, which helps bond the bricks together much more strongly. And second, it's a great spot for the manufacturer to stamp their brand name. And here is a perfect example of a tiny detail that could be a whole question on your exam. The depth of this frog isn't random. It's specified to be between 10 and 20 millimeters. It's a small number, for sure, but remembering little details like this is what can separate a good score from a great one. Okay, so we've made our brick. How do we know if it's actually any good? We test it. And these aren't just random checks. They follow very specific Indian standard codes, which, let me tell you, are an absolute goldmine for exam questions. The first major test is for water absorption. I mean, a good brick shouldn't act like a sponge, right? The test is really simple. First, you weigh the brick once completely dry. That's W1. Then, you soak it in water for 24 hours and weigh it again when it's wet. That's W2. This formula just tells you what percentage of its own weight the brick soaked up in water. So, what does a good result even look like? Well, it depends on the brick class. For a standard first-class brick, it cannot absorb more than 20% of its weight in water. For a second-class brick, that number bumps up just a little to 22%. But look at the huge difference for heavy-duty bricks, a super strict limit of only 5%. Out of all these, that 20% for first-class bricks is the number you absolutely have to remember. We also have a very specific test for efflorescence, that white powdery stuff we started with. The test is easy. You just stand the brick in a bit of water and watch what happens. The rating you give it, slight, moderate, heavy, or serious, is based purely on the percentage of the surface that gets covered by those salts. So if an exam question describes a brick with 40% coverage, you know instantly the answer is moderate. It's a direct application of this chart. All right, let's bring this all home. This is your final rapid-fire review. Let's lock in these core concepts for good. To remember the manufacturing sequence, just remember PMDB. Preparation, molding, drying, and burning. It's a super simple mnemonic to keep the whole process straight in your head.
Here's another one that trips people up all the time: brick size. A standard modular brick without mortar is 19 by 9 by 9 centimeters. But once you add that typical layer of mortar, it becomes a nice, round 20 by 10 by 10. Easy to remember.
If you only remember one number from this entire explainer, please let it be this one: 20%. That is the maximum water absorption allowed for a first-class brick. It is the most commonly asked limit, period.
And here are your final must-remember takeaways. The Pug Mill is for tempering. The frog is for the mortar key. Remember, weathering is leaving clay out, while tempering is kneading it. And efflorescence is caused by those soluble alkalis. Master these 4 points, and you are well on your way.
And I'll leave you with one final question to test your knowledge. We know the tests fall under IS 3495, but what's the IS code for the classification of the bricks themselves? It's another key standard. Go look it up, commit it to memory, and you'll be one step closer to acing that exam. Thanks for joining me.